There. This is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Today we are going to see about the synthesis of nanomaterials. So learning nanomaterial synthesis, it equips the educators and the researchers with the skills to design materials for energy storage, catalysis, and biomedicine. They're directly supporting the electrochemistry curricula like supercapacitors and batteries. This knowledge bridges the lab experiments with the industrial applications, enabling the precise control over particle size, shape, and properties. So the past interest in the solver thermal methods and the laser ablation align with creating visual aids for the students. Now let's explore the synthesis of nanomaterials using laser ablation process. Empathize. So there is need of the nanomaterials for the various applications in the field of treating cancers, then treating bacterial infections in agriculture, in biosensing, has the catalysis, and then also in the environment. So high purity nanomaterials for the advanced applications, scalability, and reproducibility is needed. Energy efficient and environment friendly techniques is also required. There is potential for diverse material synthesis. So the challenge in this is we need a precise, contamination-free, and rapid nanomaterial synthesis. Application-specific size, shape, and properties requirements, minimizing the waste and hazardous byproducts is a very big challenge in the synthesis. So the idea behind this is the laser ablation is a flexible technique. So selection of appropriate targets like the bulk materials. The bulk materials may be an alloy, a composite material. Then the optimization of the laser parameters. That is, we have to optimize the exact wavelength. The pulse of the laser have to be set right, and the energy of the laser beam should also be adjusted. So the prototype, the laser ablation setup, it shows the schematic diagram of the laser ablation system. The key components are the laser source, target chamber, substrate, gas environment. So working principle of the laser ablation process. This is step one. Is the laser beam focusing. That is, you have a high intensity laser beam. It's focused on the target material, and that is followed by energy absorption. The target absorbs photon energy, causing rapid heating. So the material vaporizes due to the heating. The surface layer vaporizes and forms plasma. So ejection and condensation. So the ejected atoms or the molecules, they condense to form nanomaterials in the required environment. So after that, you have to collect. That is nanoparticles collected on the substrate or in the solution. So implement the nanomaterials is used for catalysis, sensors, energy storage, electronics, etc. And in the biomedical uses, it's used in the drug delivery, imaging process, etc. And there is environmental remediation with the nanomaterial has a wide range of applications in many fields. So we are going to test the nanomaterial properties, that is the particle size analysis using the analytic techniques like DEM, SEM, composition and purity are verified by the XRD processes, and functional properties like surface area and reactivity is also done. So let's see the mind map of the laser ablation process. You can see the process, that is laser solid target. That is the first process. So it forms plasma, forming rapid cooling condensation, and next is gives the nanoparticles. Process parameters are laser type, pulsed NS, then wavelength, ultraviolet, visible or IR, then pulse energy, repetition, liquid, medium, water, ethanol. Then the ablation process, that is, you have the vaporization, then lamer, Oswald's ripening process. These are the different processes. Then high purity ligand free green method is also obtained by various processes. Then advantages, it's high cost, low yield, scale issues are there in this laser ablation process, which also includes the disadvantages. Then applications, they use in catalysis, biomedicine, sensors, plasmonics, and batteries. Thank you.